Well, hello again. In this example, you will practice sketching qualitative deflected shapes and identifying the direction of the resulting reactions. We're going to look at this frame, and indeed it becomes just a little bit tricky to be able to envision what goes on with this. What we want to do is identify what the support conditions are actually telling us. We know that at point C, because it's a pin, that the deflected shape must pass through here. It's free to rotate, but it's not free to move up or down, side to side. At point D, we know that it has got to come through this. Now, because it is a frame and because it's got the applied moment, we can identify basic motion of the joints. We recognize that this entire segment, because of the applied moment, is going to rotate in that direction. And thus, at joint C, we can identify that the joint will rotate counterclockwise. And so I've kind of given myself some little lead lines there indicating the direction of rotation. Well then, once I've got that, it is actually simple enough to go ahead and sketch the deflected portion of member CD. And we need to recognize that the moment wants to take all those members BC, members AB, and curve them counterclockwise. And so we're going to go ahead and get that curved counterclockwise and also curve a little bit further counterclockwise. Remember, when we sketch deflected shapes qualitatively, we exaggerate them greatly so that we can tell what is going on. Let's just be very clear that these started out as being 90-degree angles, and those need to finish at being 90-degree angles. Using summation of forces in the x direction, we quickly identify that that is going to be 0. To identify the vertical reaction at D, I want you to go ahead and remove that support at D and see what the deflected shape looks like. It would be something like this. Okay, so we know that the vertical reaction at D has got to be able to pull that back down into place. Now, you can either use the notion of equilibrium to identify that this goes in the vertical direction, just to counterbalance the reaction there at D, or you can once again remove the reaction at point C and sketch what that deflected shape looks like based upon the applied load. And you can acknowledge then that the vertical reaction at C must go in the upward direction. So this is our deflected shape, and these are the directions of the resulting reactions. And we didn't have to do any calculations at all. That concludes this example, and as always, it's an absolutely beautiful day to study structure.